No, I'm not. It doesn't work. It's got to be authentic. All right, guys. This is online here. So all you got to do is Google 2018 Environmental Science Free Response Question number 2. And we're working on the second part here. I know someone in my class that's remote asked for us to do this. And I know some of y'all are still having trouble with the math, so hopefully we can work this out. So part D, what did we say, Rachel, what are we looking for?
The 80% of the demand per year.
What's the unit we're looking for in the answer?
Yeah.
So we're looking for megawatt hours.
Yeah.
So megawatt hours, and so we're going to use dimensional analysis here. And really, we don't even need to use dimensional analysis for this because all it's asking is what? We're looking for the amount of energy. So this project area can be served, or is going to be using 2 million megawatt hours, which sounds a lot like 2 trillion to me, to be honest. But if wind energy produces 80% of that, all you got to do is that 2 million, or 2 times 8 times 10 to the, or 2.0 times 10 to the 6 megawatt hours.
0.8.
Times 0.8, and so that will give you 80% of the energy produced from wind energy. Okay, and so that should be 1.6 times 10 to the 6, or if you write it out, it's going to be 1,600,000. Yeah, because that's 6 places over. Megawatt hours.
That's what I did, but I didn't know that was the answer.
Well, what did you think was the answer?
I don't know.
Well, that's all it asked for. That's okay. Part E. What are we looking for in Part E? Who wants to do this one? Good. Luke. What are we looking for?
You're looking for the amount of money how much revenue you'll make from the wind turbine.
Okay, so we're looking for dollars.
Yeah.
What do we know about dollars on the other side? So dollars has to be on top.
It costs 20 cents for 1 kilowatt of electricity.
Yeah, so we know that it's $0.2 for every 1 kilowatt hour. Now, that should be what your power bill is. I got to look at my power. Did anybody look at their power bills over the break?
No.
We should have done that for extra credit. Maybe I'll throw that in for extra credit. We'll do our power bills and we'll see what our power is for the month. How much? I'm not really worried about the cost. I'm more worried about like how much energy you're using. So let's see here. Customers pay 20 cents per kilowatt hour. That's highway robbery. I think ours is about, I want to say about 12 cents per kilowatt hour, but I'm sure different places it's different amounts. And did you know that the rate of the electricity rate changes based on demand? So like in the summertime, if you're turning your air conditioner up and everybody's got their air conditioner running wide open, the power company charges you more than they do like at night in the summertime when not as many people are running their air conditioners. So they're actually poking the bear there, trying to get all they can out of you. All right, so calculate how much revenue will be produced at the 80%. So we've got to get from kilowatt hours, and we've got to get rid of kilowatt hours some here. So what else do we know about how much energy we're using?
It's
1 million kilowatt hours.
Well, we're using the 1,600,000 megawatt hours, right?
But there's 1,000 kilowatt hours in 1 megawatt.
Okay, yeah, so we got to get from kilowatt hours to megawatt hours. So there's 1,000 kilowatt hours in 1 megawatt hour. So that's going to cancel out. And then we used, for the project, there's 1.6 times 10 to the 6 megawatt hours. And so our megawatt hours are going to cancel out. And you multiply these together, and the cost will be
$320.
$320?
320 million.
Yeah.
320 million. You left out a few zeros. So
Well, I wrote like 320 and then 10.
that's okay. 320, better than 420, am I right? All right, number 4. All you crackheads out there know what I'm talking about. Number 24, excuse me. Assuming all turbines are operating, calculate how many hours the wind turbines must operate to provide 80% of the annual electricity demand in the service area. Have y'all got to this one yet? This was, yeah, Donovan, what's up? You want to do this one? Okay, what are we looking for, Donovan? Okay, so we're looking for hours. Okay, so hours has got to be on top. I'm just going to put H for hours since that's how it is in kilowatt hours. And then, what do we know about hours?
That 1,600,000
Show like comment on
megawatt
our videos.
per hour for each turbine. Right, no.
Well, hold on. So, all turbines are operating. Calculate how many hours the wind turbines must operate to provide 80%. So, how much energy are they providing? That's the first thing we need to look at.
For each turbine.
No. We're not there yet. So, the total energy is 1.6 times 10 to the 6 megawatt hours, right?
Yes.
So, that's the 80% that they're looking for this project. Now, what did you say about each turbine?
Each turbine uses up about 4 megawatts per hour.
Okay, so for every one wind turbine, I'm just going to put WT, it produces how much?
4 megawatts per hour.
Well, we're just going to say 4 megawatts. That's its capacity. Okay? So what that does is it gets rid of our megawatts here, and then it gets rid of our megawatts there. So, and then we've got to get rid of what? We're down to hours, but we still got wind turbines. So how many turbines do we have running?
200.
Okay, so we've got 200 wind turbines, and so wind turbines cancel out, and we're left with, the only thing we're left with is hours, and when you calculate that out, how,
2,000 hours.
2,000 hours is what we're left with. Good. So that is your answer on part F, 2018.